At HQS, we have developed the Struqture library to create, store, and exchange spin Hamiltonians for quantum advantage use cases. In this video, we compare Struqture with other often used frameworks, going to sizes relevant for quantum advantage. If you want to know more background about Struqture, we invite you to watch our other videos. To remind you, in Struqture we construct spin Hamiltonians from products of Pauli operators. Each product of Pauli operators can be written as a string of qubit spin index and the operator on this index. Each spin index not appearing in the string does not interact and corresponds to the identity operator. This notation is simple compared to notation requiring us to write down full matrices, and it is compact compared to methods that require to define identities explicitly. Let's compare creating a Hamiltonian in Struqture with Qiskit and QuTip. In Struqture, we just add the two products of Pauli operators to construct the Hamiltonian. In Qiskit, the Hamiltonian is constructed similarly, but Qiskit requires us to list all the identities in each product of Pauli operators that contribute to the Hamiltonian. In the case of 4 qubits, far away from quantum advantage, the code is only slightly longer. In QuTip, the Hamiltonian is stored in matrix form. One must first define the Pauli matrices used to construct the Hamiltonian and then explicitly construct the tensor product of the correct operator for each qubit, including the identity operator for each qubit not involved in that term of the Hamiltonian. Since our goal is a software library that can be used to create, store, and exchange inputs for quantum advantage use cases, we need to compare the frameworks in the regime of potential quantum advantage with more than 50 qubits. For Struqture, nothing changes compared to the 4 qubits case. Only the qubits the Pauli operators act on are changed. In Qiskit, we need to keep track of a large number of identities. Qiskit can construct Hamiltonians in the quantum advantage regime of over 50 qubits, but keeping track of the right number of identities becomes unwieldy. In Qubit, the situation is more challenging. Not only does the code become much longer and harder to keep track of, a 51 qubit example cannot be stored in memory. Instead of the 51 qubit example, we show a 21 qubit example that can still be constructed on a normal laptop. In conclusion, only requiring to provide the minimal information to construct Hamiltonians and handling identities and zeros implicitly makes Struqture ideal to construct inputs for quantum advantage use cases. If you got interested in Struqture, it is open source and you can have a look at it on GitHub.